Hello there, Mr. Sutton here with the AB Calculus 3-5 Part 1 homework solutions on the product rule. On this problem, I'm trying to find the derivative of this function with no simplifying required. So I'm going to do this using no product rule, and then I'll do it again using the product rule just so you can see both approaches here. So this one's a little bit faster without the product rule if you needed to simplify. So we're going to start by just distributing this out using FOIL. So we've got 4x times 3x is 12x squared. And then we have 4x times negative 5, that's going to be negative 20x. Doing the rest of them now, this is going to be negative 6x cubed. And then negative 2x squared times negative 5, that's 10x squared. Collecting like terms, we've got this negative 6x cubed that can come out in front. We have a 22x squared and a negative 20x when all is said and done. And now just using power rule from left to right, this will be negative 18x squared plus 44x and then minus 20. Now I'm going to show you how to do this problem using the product rule, just in case you did that method. So I'm just going to write it out first, u prime v plus uv prime. And then let me set up my box and ribbon for this. So I've got u, that'll be my first factor here, 4x minus 2x squared. And then v over in this box, this is going to be 3x minus 5, the other factor. Down below we've got their derivatives, u prime and v prime. U prime, that's going to be 4 minus 4x. And then v prime, that's just going to be 3. Doing our ribbon now, we've got 4 minus 4x in a parentheses times 3x minus 5 also in a parentheses, plus parentheses 4x minus 2x squared times 3. And again, no simplifying required, so I'm not going to go ahead and simplify this, but I could if I wanted to. On this problem, we're being asked to figure out the derivative using a product or quotient rule on this. Now, you could have distributed this and just use the power rule, but they said to use product or quotient rule, so we have to use that instead. Product rule, obviously, on this one because we have a product. So that's going to be u prime v plus uv prime. Using my box and ribbon here, I've got my two factors, 5x squared and 4x to the fifth minus 1 in there. And their derivatives down below, we're going to have 10x followed by, this will be 20x to the fourth. Now using the ribbon to put it all together, I've got 10x times 4x to the fifth minus 1, and I'll need a parentheses for the second thing there. Plus, now I'm going to do uv prime, 5x squared times 20x to the fourth. And they said no need to simplify, so we're just going to leave it like that. For this problem, we're being asked to figure out the derivative using a product or quotient rule. This one's actually going to be a product rule because we basically have 3x minus 1 times itself. Now, if you knew the chain rule, that would be even faster, but you might not know it yet if you're doing this as part of the 7-5 extra practice. So let's go ahead and use our product rule, u prime v plus uv prime, and then we'll have our box and ribbon. Our two factors are going to be 3x minus 1, or 3x minus 11 rather, and also 3x minus 11. We're multiplying something by itself here. The derivatives of those are both going to be 3. And then using our ribbon to put it all together, we've got 3 times 3x minus 11 plus 3x minus 11 times 3. They said no need to simplify, so we'll just leave it like that. For number 4, we're given this table of values for f and g and their derivatives at the x value 1. And we want to know what h prime of 1 is, where h is this crazy product here. Since h is a product, I think product rule is a good way to go on this one. So we've got, in general, u prime v plus uv prime. Let's set up the box now and plug things in where they need to go. So for my top of my box, I've got the two factors, 2 times f of x plus 3 and 1 plus g of x. For the bottom now I have to take their derivatives. So this is 2f prime of x. 3 goes away because it's a constant. And over here we have g prime of x. And I'm going to rewrite my box again with 1 plugged into all of these. I think it's easier to do it that way than rather than rewrite all of this over here and then plug in. Just saves a little time. So if x equals 1, here is what my box will now look like. We have 2 times f of 1 plus 3. Well, f of 1 is 3. 2 times that plus another 3 gives us 9. We also have 1 plus g of 1. g of 1 is negative 3. 1 plus that gives us negative 2. Now we have 2 times f prime of 1, so that's 2 times negative 2, which is negative 4. And g prime of 1 is just 4. We don't have to do anything else special with that. So doing my ribbon now, I've got negative 4 times negative 2, and going the other way, plus 9 times 4. That's going to be 8 plus 36, which is 44. Choice D. On this problem, we're given two functions, f and g. We're told that g is positive for all x values, and f of 0 is 1. So you could at least use that to maybe narrow down some of the answer choices here. And then there's this crazy bunch of stuff here. H of x is f times g, h prime of x is f of x times g of x. And based off of all of this, they want us to tell them what f of x actually equals. All right, so the key on this one is that h, which a lot of this is based off of, is a product of f and g. So since it's a product, we can use the product rule on it. We can say in general, h of x is going to be u prime v, so f of x times g of x, plus uv prime, so plus g of x times f prime of x. This is just if you wrote it out with the product rule, knowing what you know about that rule. Now, they gave us a little more information here. They told us that h prime specifically for these particular functions is just f of x times g prime of x. So we could actually replace the h prime here with f of x times g prime of x. Now, the reason this is important is because we've got an f of x, g prime of x on the right side of this equation. So we could actually subtract that from both sides, and then we would have f prime of x, g of x just equaling 0. Now, why is this important? Because we can do a little bit more digging here. We were told that g of x was positive for all x values. Well, if g of x is positive, and when I multiply it by f prime I get 0, that means f prime itself must have a value of 0. There's no other way for that to happen. Now, the reason this is important, f prime, if that's 0, that tells us that the slope is always 0, which means we're dealing with a horizontal line for the original f function. And this is what we wanted to figure out, right? What the original f function was. There's only two functions here that are horizontal lines necessarily. That's going to be d and e, but which one is it? Well, here's the last piece of information that was helpful. They told us f of 0 is 1. In order for the f function to go through 1 and be a horizontal line, it must be the horizontal line f of x equals 1. So that gives us answer choice E. For this problem, we've got the graphs of f and g shown up here, and we're told that h of x is f of x times g of x. Based off of this, we want h prime of 6. All right, well, the idea here, we need to take the derivative of this product, which we're going to need the product rule for, and then we need to plug 6 into it. So let me write out my product rule. That's u prime v plus uv prime, plus in there because it's product, not quotient. So let me set up my box and ribbon to organize things. I've got f of x and g of x, my two factors, and then their derivatives, which are f prime of x and g prime of x. Now, I could multiply all this out and set this up and then plug 6 into it, but I'm actually just going to plug 6 in directly inside the box, and then I'll put it back together here. So here's another box, and in here I've got f of 6. Looking at my graph now, let's see, the x value 6, that's right here. F of 6, this is the f function right here. This is going to be a value of 2, so just careful doing this. And then g of 6 is right up here. That's a value of 4. Now we need f prime and g prime of 6. So back to the x value 6. On the f graph, we have a slope, an f prime value of, let's see, down 2 over 1, so negative 2. Coming up here to the g function, this slope appears to be negative 1/2 at that spot. Let's put it all together now. We've got negative 2 times 4 plus 2 times negative 1/2, or minus 2 times positive 1/2. Either way you slice it, you've got a negative going on over there. So this is, we got to simplify now to get an answer choice. So we've got negative 8, and this is going to be minus 1. So that's a grand total of negative 9. giving us answer choice A. On this problem, they're asking which of the following expressions can be differentiated using the product rule. Well, as we look at all of these, the only one that actually contains a product is choice B. So that's the one we're going to pick. A, this is a composition of functions. We've got a function inside a function. C is two things being added together. And D is another composition of functions. On this problem, we're given the f function here, which is a polynomial that has this mystery b constant in it, multiplied by some g of x function that they didn't actually tell us what it does, other than the fact that it's differentiable. They did tell us that g of 2 is 3 and g prime of 2 is negative 1, which will be useful, but we want to know what the value of this b is, given that f prime of 2 equals 0. So overall strategy on this, we basically need to figure out an expression for f prime of x, plug 2 into it. We're going to get some stuff that has a b hanging around, and then if we set all of that equal to 0 and solve for b, we should get what we're looking for. So in order to take the derivative of f, we are going to need to use the product rule, u prime v plus uv prime, and for that I'm going to use the box and ribbon to help me organize things. So I've got the first of the two factors in the upper left here. That's the x cubed plus bx plus 6. In the upper right, I've got the other factor, g of x. That's the v in this problem. And down below, I'm going to put their derivatives. So for this one, we've got 3x squared plus just b, because b is a constant. And over here, this is just going to be g prime, because we don't really know what it does otherwise. Okay, so if I plug 2 into this thing, I should get an output of 0. So let's say that x does equal 2. What do each of these things become? I'm going to just plug things in inside the box here. Then I'll throw it out together in this equation over here. So if x equals 2, this upper left now, this is going to be 2 cubed plus 2x plus 6. So that's 8 plus 6, which is 14. So 14 plus 2b. And then over here we've got g of 2. Well, g of 2 they told us is 3, so we'll just put that in there. And now down in the lower left, we've got 3 times 2 squared, which is 12, plus b, and can't really simplify that any further. And then finally, g prime of 2 they told us is negative 1. So multiplying all this out, we've got b plus 2 times 3, or 3b plus 36, if I multiply that out. And then going the other way here, we're just multiplying 2b plus 14 times negative 1. So that's going to be negative 2b minus 14. And they told us that all of this should equal 0 when I plug 2 into f prime. So simplifying the left side a little bit, this is b plus 22 equals 0. So therefore b must have a value of negative 22. So that's going to be choice D. For this problem, we've got the graphs of differentiable functions f and g given up here, and they're defining the p function as f of x times g of x. We want to know what has to be true about p prime. Okay, so this is a little bit different. First off, we don't know any exact values. I mean, we do have some possible exact values because they gave us grid lines, but nothing is really certain. They're basically asking if the derivative is negative, 0, or positive at x equals negative 2 or x equals 0. We've got this other possible x value going on. So all of these are going to require us to have some kind of setup for p prime. Let's get that now. If p is this product here, then to get p prime, we're going to need the product rule. So let me write that out as u prime v plus uv prime in general. And now let me set up my box and ribbon to organize all this. That's going to be f of x and g of x up here, my two factors, and their derivatives, f prime and g prime. Okay, now I have to plug a few things in here. Let me start by plugging in negative 2. I'm just going to go in numerical order. If I plug negative 2 in for my x value, and I'll do this directly inside the box here, I've got f of negative 2. So here's the x value, negative 2. On the f graph, that is clearly 0. And now we have g of negative 2. That's over here, down right here. This is going to be, it looks like it's exactly negative 4, But I'm just going to make it negative in general because these are all talking about, greater than or less than 0 kind of situations. So we don't really need the exact value to do this. So I'll just say negative. And that's how I'll show that that's negative. All right, f prime of 2. So back on the f graph, we have a positive slope for the f function. So that's a positive f prime value right there. And now we also have g prime of negative 2. That's down here again. Since we have a smooth turnaround going on down here, this is going to be a slope of 0. Now putting all this together, we've got, using my ribbon here, we've got positive times a negative, that's the u prime v, minus 0 times 0, so that's just 0. So I'll say plus 0. Actually, it's plus, not minus, but either way, it's 0. So we have 0, which we don't care about, and a positive times a negative, which is a negative. Overall, that gives us a negative answer, which is going to match answer choice A. So A is looking like a pretty good candidate. We can clearly eliminate now B and C. But if you're curious, let's plug 0 in and see what happens. So if x equals 0, so this is if you had nothing else to do and you wanted to really just confirm the kill on this question. So we've got f of 0, which this is all on the y-axis, so it's a little easier to read all this. F of 0 is a positive number. G of 0 is a negative number. And now f prime of 0, we have a turnaround there, so that's going to be 0 for the slope. G prime of 0, we have a positive slope, so positive g prime down there. Putting that all out here, we've got 0 times a negative plus a positive times a positive. 0 times a negative is just 0, so this all ends up being greater than 0 when all is said and done. And that's not even one of the other answer choices. So then we can conclusively pick answer choice A. For this problem, we've got a graph that has f and g on the same x and y axis, and we're told the h function is f times g. Based off of this, we want h prime of 2. Well, we've got a product. We need the derivative of a product, and there's no way to simplify before taking the derivative, so this one is going to be product rule or bust. So let me write out our product rule. That's u prime v plus uv prime. I always like to write that out, so I've got it organized. And then let me put my box and ribbon over here so that I can keep my information even more organized. I've got my two factors, f and g, and their derivatives, which are, well, big surprise, f prime and g prime of x. So what I have to do is actually plug 2 into this derivative. I'm going to do that directly inside the box that I just made here. So let me just rewrite these now. This is going to be f of 2, which means I'm going to have to look up the value of 2 on the f function on this graph. So at an x value of 2 right here, the f graph is reading, let's see, this is 3. Now we need g of 2. So now I look at the g function on the graph. G of 2 here looks to be 1. And I also need f prime of 2 and g prime of 2. F prime of 2, back up here on the f graph, this is going to be our slope at x equals 2. It's a straight line, so we just have to read the slope anywhere on here. This is going to be up 1 over 2, so that's 1/2 for f prime of 2. And now for g prime of 2, that's going to be the slope on the g graph at x equals 2. We're going down 2 over 1, so that's -2 for that slope. Putting it all together, we've got u prime v, so 1/2 times 1, plus uv prime, so plus 3 times -2. The answer is, of course, simplified, so let's go ahead and do that here. This is 1/2 minus 6. Well, that's really 1/2 minus 12 halves, which is -11 halves. So that's going to be choice D. For this problem, we're going to have to think a little bit outside the box here. We've got the graph of two functions, f and g, and we're told that p of x, it's a new function, is the product of f and g. We want to know which of the following statements about p prime of -2 is true. So we've got it could be negative, 0, positive, undefined, or we just simply don't know. So it's usually never going to be one of these not enough information kind of deals. But let's keep going and see where this shakes out. So because I have a product, let's start there. I'm going to need to use the product rule. So that's u prime v plus uv prime. And hopefully we know enough about all these things in order to make some conclusion. So I'm going to use the box and ribbon to organize my information. So I've got f of x and g of x, my two factors up there, and f prime and g prime down below. Now I'm actually going to have to plug in -2 for x. So let me do that directly inside the box. So at x equals -2, these four things have the following values. Let's check it out. So we've got f of -2. That's the value of the f function at the x value -2. So that's right here on the f graph, and that's crossing the x-axis right there, so that is clearly a value of 0. So this is good. We already have a number to plug in. Now we need g of 2. So looking at the g graph at -2, I should have said g of -2. This is going to be down here somewhere. Now I have no idea what y value this is. I could guess, but they didn't even give me a scale on the y-axis. So guessing is probably a very bad idea here. But I do know this is below the x-axis. So at the very least, I can say this is a negative number. So I'll put a little negative here to represent that. Okay, let's check out f prime of -2. So that's the slope at -2 here. Now, I don't know what the slope is exactly, but we're increasing on the original function. So that means f prime itself must be a positive number. And hopefully that'll be enough to get me one of these answer choices when all is said and done. G prime of -2, well, that's right here. G function is also increasing down there, so that's also going to be a positive number for G prime. Multiplying it all out now with the ribbon to get my product rule, I've got positive times a negative here, this is u prime v, plus 0 times a positive, this is uv prime. So this first term here is going to have to come out negative because it's a positive times a negative. The second term is just going to be 0 regardless of what else is going on because you've got 0 times something. So when all is said and done, because this first term was negative and the other thing was 0, this comes out to a number that's less than 0, that's negative, and that's actually enough to pick answer choice A. On this problem, we're given a table of values for f and g and their derivatives, and we have this h function here, which is f of x times g of x. Based off of that, we want h prime of 2. So this is a product rule waiting to happen. We've got u prime v plus uv prime in general. Let me set up my box and ribbon now to see where things play out. So I have my two factors, f of x and g of x, and their derivatives, f prime of x and g prime of x. If I'm trying to find h prime of 2, basically I need to use my product rule and then plug in 2. I'm actually going to do all of the work inside the box, though. So if x equals 2, here's what all of these four things should be. F of 2, that's going to be in my table. That's right here. That's 3. G of 2 is going to be 3 also. F prime of 2, also in the table. That's -1. And then G prime of 2 is this 3/2 over here. Using the ribbon to put it all together, I've got -1 times 3. And then I'll be adding 3 times 3 over 2. Now, there was no need to simplify, but if you wanted to, this is -3 plus 9/2. Well, that's -6/2 plus 3/2, or 9/2 rather, which is going to be +3/2 when all is said and done.